Okay, so we saw that logarithm and logarithmic functions and exponential functions, they are just the inverse of each other, as we saw in this picture. So this is a typical exponential curve. We can assume this b is just, let's call it 2. And if we just take image of this curve in the line y is equal to x, that gives us inverse of this function, and that inverse function is called logarithmic function. And so the main thing is, to understand logarithmic functions, we just need basic understanding of exponential functions. So we started with exponential functions, and we declared that they come in two families. One is increasing family, in which case bases are greater than 1, and then we have decreasing family, where bases are less than 1, and they are always positive. When we talk about exponential functions, we assume that base is positive. The ones with negative base, they are not treated as exponential functions because they don't inherit those properties. And so we have seen the behavior in these two classes. So when bases are greater than 1, we can talk about 2 power x, and if we just apply some inputs and collect the outputs, and we just plot them and join them, we get an increasing curve. So we can take any base greater than 1, we are going to get increasing curve, and it will always pass through 0, 1. So it will leave an intercept of 1. So every exponential curve, it leaves intercept 1. And if we go on the other side, in the decreasing family, then if we just apply some inputs and just plot the points and join them, we get a decreasing curve. And again, the intercept is going to be 1, so every decreasing exponential curve is going to pass through them, pass through this point. So these are main points for exponential functions. So we are pretty familiar with the exponential functions, and we are just looking at mirror image of these functions now, which we call as logarithmic functions. So after this introduction, let's now introduce the formal structure. So when I write y is equal to b bar x, I will always assume that this b is positive and b is not equal to 1, which essentially means that either base is between 0 and 1 or base is greater than 1. So we are talking about both the families. So this is what we call as exponential format. Exponential format. And we are used to writing this type of format. Now we are introducing a new kind of format. We will be writing exactly the same thing. So this thing I can express in another way, and that we call as logarithmic format. So let me first write it, and then I will put surround it by some words. So here I will write x is equal to log of y, and base is written here. So what is the primary difference between these two things? The role of input and output has been exchanged. So when we write equation in this way, we understand that this x is the input, b is just fixed, b is constant. Let's take b to be 2, so it's constant. So x is the input that is being provided, and then we are collecting outputs for the corresponding values. So this is input, this is output, y is output. So if I want to exchange this role, that's what we have done here. So in this equation, I understand that this y is going to be, y values are going to be provided, and then we are going to collect the values of x. So let me express it using an example. So we always write that 2 power 3 is 8. So this is exponential format. And I can express the same thing in logarithmic format. In that case, I will write this as, so let me color this thing. This is base. Everything is happening with respect to some base. So base here is 2. And 3 was the input that was provided, and the output was 8 that we collected here. Now I want to understand, so what is logarithmic format? A format in which we ask this question. So let me put it in this way. So here we were asking this question, that what is the output when 3 is supplied to the exponential function where base is 2. So what is 2 power 3 inherently? That is the question. So now I will ask the same question, but in a different way. So let me mark the space separately. So now my question is, what power of 2 gives us the value 8? So we can see that inherently these questions are same. The only difference is where this question mark is placed. And since we don't like the question mark in this awkward position, so we have designed a specific format to write this thing. So how do we write this? So we'll just say, what is log 8 base 2? What is that? So this notation is just representation of this. There is no difference. And we call this function, taking inputs over here, we call this function logarithmic function, and this base has to be specified along with, so we will call it logarithmic function with the base 2. Right, so I hope I have conveyed the basic idea about logarithms. So when we write what is log x base b, if I write this to be y, I can think of this thing at the back of my mind as x is equal to b power y. So b remains b, and the role of input and output is exchanged. So x was input here, now it's output. Y was output here, now y is input. So the role has been exchanged. Base is base. Right, so if we understand this thing, then everything becomes very clear about logarithms. There is no need to worry about the properties and graphs. Everything comes out naturally just using the exponential functions. So let's describe the logarithmic families now formally. So logarithms, because we are just inverting exponentials, so they also come in two families. So one is going to be increasing family. Let me put it here, increasing family. And the other one is decreasing family. And we already have the idea that the increasing family will be corresponding to bases which are greater than 1. And decreasing families will be when bases are between 0 and 1. So let's take up some examples. So here I will be plotting y is equal to log x base 2. Let's study this thing. And so for time being, let's forget about logarithms as inverses of exponential. Let's try to understand logarithmic function itself. So when I am writing this, because this notation is new for us, so we don't like to work on this at this point of time, so I will just convert it into the exponential format. So writing this thing is exactly same as writing that x is 2 power y. So these two things, as we have discussed, they are same. So now I will collect some points from here. So what are my points? Let me write them over here. So what are my points? If I put y to be 0, I get x value 1. And if I put y to be 1, I get x value 2. On the other side, if I put y to be -1, I get x value half. I think with these 3 points, we'll get the idea for the curve. So let's draw it. So this is my input and output axis, and I'm going to plot these points. So I have 1 0, 1 0 is going to be here, 2 1, 2 1 is going to be somewhere here, then I have half and -1, so that is going to be here, and we get the idea that if I join all these points, the curve is going to look like this. So this is 1, and this thing is happening at 2. This point is -1. And so, yeah, this thing is half -1. So this is -1, right? So this is the curve y is log x base 2, and we can see that this is still an increasing curve, and so that's why this title has been provided to them. And if we just take replace this 2 with 3, so that is just going to give me corresponding points. I'm going to get this point will shift here. If we are talking about 3, then the output will be 1 corresponding to 3, so that point will come here. So log x base 3 will be curve like this. It will again pass through 1, so this point will be common. As we have seen in exponential functions, this intercept on y 0,1 was common. Here this will be common. Anyway, so we have a lot of time to discuss all those features of the families, but the main thing is whenever base is greater than 1, the curve will look like this. It will pass through 1 always, and it's an increasing curve. And on the other side, if I take up an example here, let me take half. We choose half as the base for this example, for a decreasing family. And again, since we are not familiar with properties of logs, we are just introducing it, so I will convert it into corresponding exponential format. So our x is going to be half power y. And if we just collect some points from here, again, if I place y to be 0, I'm getting x to be 1. If I place y to be 1, I'm getting x to be half. And if I take y -1, then half inverse is going to be 2, so x is going to be 2. And if we just quickly plot these points on these axes, then what do we get? So I have 1 0, which is this point, so this remains same, and then I have half 1, so half 1 is going to be somewhere here. Then I have 2 -1, 2 -1 will go somewhere here, so let me label them. This is 2, this is 1, this point is 1, and this side over here, this is -1. So these are my points. So we can see the behavior. So if I just join these points, I get this kind of curve, and that is inherently a decreasing curve. So that's why this title has been given, decreasing family. So we have got two families for logarithmic functions, as was the case for exponential functions. Decreasing family, whenever bases are less than 1, they're always positive, and increasing curves when bases are greater than 1. So with this, now we have formal definitions for logarithmic functions, and we will get deep into this, and we'll work out some properties. We'll study properties of exponential functions, which we are already aware of, and we'll just convert them into corresponding properties of logarithmic functions, and then from there on we will start solving related questions. Right, so that's it for now. Bye-bye.